friends, I am Vaibhav Srivastav from Vaibhav E-Learning Academy. Today we are going to start a new topic in physics, that is Newton's laws of motion. This is our part number 1. In today's video we will be discussing about the first law of Newton. So there are 3 laws of motion and about each law there will be a separate video. This video is about the introduction to the Newton's first laws and then what are the basic Newton's laws of motion, and in today's video we will be covering what is force, then what are the basic types of force which are needed for this chapter. There are many types of forces, but for Newton's laws of motion, what are the forces which you need? We will be discussing about those kind of forces. Then we will discuss about the Newton's first law of motion in detail, what is the first law of motion, and then we will solve many numericals regarding this laws of motion. We have so much numericals for this Newton's first law of motion. So today we will be starting the Newton's laws of motion chapter, part number 1. So Newton's laws of motion. So before moving on to the Newton's laws of motion, think about everyday example. For example, you take a block and you want to move it from point A to point B. So if you want to move a block from point A to point B, you have to constantly apply force on it. So let me explain this. For example, there is a block over here, block of mass m. The box is actually in the rest. You want to move this box from this area to this area. So from this point A to this point B, if you have to move the block, you have to apply something which is known as force. So you have to apply some force on the block so that the block moves from this position to this position. So here the box has changed its place. The block has changed its place from point A to point B. And how did it change the place? Because we applied some external pressure on it. We applied some force on it. So what is force? Force is a thing which helps in the motion of a body. You can say force is actually like we are providing force to an object. Force is a thing which causes the push or pull of an object. We know force is push or pull on an object. But force is the thing which helps in the relative motion, or it helps in the motion of the body. It helps in the motion of the body. It can also help in starting the body or stopping the body. Now here the block is at the rest. It is stopped. Sorry, it is going to start. It is in rest. You apply force, the block moves from here to here. Let us suppose the block is already moving and you have to stop it. Then also you will have to apply a force, but in the opposite direction. So force can either stop the relative or can stop the motion or can start the motion. This is another thing. So force helps in the motion of the body. Now this force can be of so many types, but the main forces which we will be discussing are, first one, gravitational force. Gravitational force. Second one, we will be discussing about normal reaction or normal force. Third one, we will be discussing about tension. Fourth one, we will be discussing about spring force. So gravitational force, normal reaction, tension, spring force. We will be even one more thing, that is pseudo force. Fifth one, pseudo force. We will also be discussing about friction. So these are all the types of forces which we will be discussing throughout the chapter of Newton's laws of motion. So we won't be discussing about each and every type. So in today's video we will cover mostly the gravitational, normal and tension, spring force, pseudo force and friction. On spring force there will be another video, pseudo force there will be another separate video, and for friction, that is actually a big topic. We will be discussing about types of friction and static friction, kinetic friction. That is another topic. So these things we will be discussing later on. Today's video we will discuss the basic of what is gravitation, normal and tension, because these 3 forces will be used a lot in the Newton's laws of motion. So starting with the first one, The first force here in the list is gravitational force. Gravitational force. So what is gravitational force? Now suppose there is a block over here. Block of mass m. It is lying on a table, for example, a table. Now, here is the surface of the earth. Now the surface of the earth, the gravity will be acting towards where? The gravity won't be acting downwards. It will be acting towards the center of the earth. So, here. So, there is a difference between mass and a weight. Mass and weight. So, what is the mass of this body? The mass of this body is m. But the weight of the body, so here mass is m, but the weight of the body is mg. Mass into gravitational. Now here g will be representing with 9.8 meter per second square, or g is equal to 10 meter per second square. In most of the cases, in today's video, we will be taking g is equals to 10 meter per second square and we will be solving our problems. So here there is a block of mass m. This block of mass m, the earth will apply a gravitational force on the block of mass m. So the block will apply a force downwards, that is called mg. This force is gravitational force. Now suppose there is an inclined plane instead of a block over here. This is called an inclined plane. Now if there is a block of mass m over here, if you are saying gravity will act downwards, then this will be acting down, like for this the downward will be this direction. This is the downwards for the wedge. But here actually it is not acting downward. As I said, it will be acting towards the center of the earth. So for example, this is the wedge. This is placed on the earth, something like this, right? So the block of mass m, center of the earth is like this. So the block will act mg like this. The weight of the block will act like this, towards the center of the earth. In this inclined plane situation, we won't be taking mg, we'll take here components mg sin theta and here mg cos theta. We'll discuss later on in the video. So this is one example. Now what if there is a circle over here? Now there is a block of mass m over here. Mg will be acting towards the center of the mg, like center of the earth. Here there is a block. Here also it will be acting towards the center of the earth. So this is called, here actually this you are taking as the earth, for example. Anywhere on the earth. If this is the earth, then the mass, the weight, the gravitational force will be acting towards the center of the earth. This was the first type of force, which is called gravitational force. And the gravitational force, acceleration due to gravity, the value is 9.8 meter per second square. But for our convenience to solve the equation, we will be using as 10 meter per second square. Second type of force is normal. Normal force or normal reaction. So this will be represented as N or R. But we will be representing it as S because it is like N, because it is convenient. So N and R. R stands for reaction and N stands for normal. So normal reaction. Now what is normal reaction? So the force applied perpendicular by the body on the by the surface perpendicular to the body. Perpendicular to the surface is called normal reaction. So for example, here we are having a table. Here there is a block of mass m. Now if you want to find the normal reaction, you have to take perpendicular to the surface. So perpendicular to the surface is like this, normal reaction. Take an example of an inclined plane. There is a block of mass m over here. Weight mg will act downwards and normal reaction n will act like that. if you are taking this earth over here directly, or a circle, you can say, or earth. In the earth, if you put block of mass m over here, normal reaction will be like this. If you put a block of mass m over here, this will be the normal reaction, and the mg will be towards the center of the earth. This is, we are assuming this is as earth. So this is called normal reaction. The force applied perpendicular to the surface. This is a table, perpendicular to the table is called normal reaction. Perpendicular means 90 degree. So perpendicular means 90 degree. So from the surface 90 degree. From the surface 90 degree. Here if you are taking a small, so here it is a circle, but if you are taking a very small portion of that circle, then if you suppose, like if you take only this much part of it, it will look like this, perpendicular. So this is also one normal reaction. So this is called normal force or normal reaction. Now the third type, which we'll discuss in today's video, and the last type of force, is called the tension. The third type is tension. Now, tension force. This force acts in the case of, it acts in the case of thread or string or rod. It acts in the case of a thread or string or a rod. And one more very important point is, tension does not change. Or else you can write it another way. Tension remains same until or unless the string is changed. So tension remains same until or unless the string is changed. So for example, we are taking a block over here, mass m. We are connecting this block, let us say this mass m1. We are connecting this block with another block, mass m2, and this is the tension. Now this is the string, this is the string. Now here tension, one more point which is important. So tension acts away from the body. Now this is a string. So here how the tension will act, I'll explain in a second. Tension always acts away from the object. So now for example, this is one block of mass m1 over here. This is a block of mass m2 over here, and you are pulling it with some force F. Okay, leave it. Block of mass m1 and block of mass m2, and you are pulling it with some force F. Okay. So here tension always acts away from the object. Now if you want to find the tension at this spot over here, you will find it away from the object. So the object is this side, the tension will be away from the object. Similarly in M2 case, the tension will be away from the object. If you didn't understand, I'll explain you once again. So these are the first 3 points. It acts in the case of thread, string or rod. Tension remains same until or unless the string is changed. I'll discuss about this now. And tension always acts away from the object. Okay. So for example, there is a block of mass m1. Here there is a block of mass m2. Here there is a block of mass m3. And we are pulling it with some force. Okay. So actually this kind of cases will come in Newton's second law, because here force is coming. So F is equal to ma. That is second law, but for tension I am giving the example. So here is the string. At m1, if you want to find the tension, here the tension will be away from the object. Here tension T1. Similarly, if here you are seeing the tension over here, this will also be away from the object. This is also tension T1. Why are they both T1? Because here the string is same. I said the tension does not change until or unless the string changes. Here the string is same, so the tension is also same. Now if you see here, this string is changed. A block of mass m1 is connected to m2, then m2 is connected with another string to mass m3. So this string is different and this string is different. So here the tension will be changed. Here tension will be away from the point T2. Here m3 will be tension here will be away from the point T3. This is how you find tension or how you mark tension. Another case, this case will be discussed too much in the next video, second law of motion. This is one pulley, and here there is a mass m1. Here there is a mass m2. This is connected by a massless string. Massless string. In like as slowly if you increase the difficulty, they will also give you the mass of the string. But most of the cases it is massless string. Then if you want to find the tension, now let us take this is the pulley. So for mass m1, tension will be acting away from the point. So here the tension will act as T1. Point m2, the tension will act away from the body. Here also will act as T1. Why T1? Because the string does not change. The same string is over here, it is being turned to the pulley and come back down. So the string is same. But here the string is different. This is also connected by some string or rod, right? That is different. So here the tension applied will be T2. That is how you mark tension. Now this will be in the cases of only a massless string. So this is, I guess, these are the three types of forces which we'll be discussing in today's video. Now this tension, gravitation force and normal reaction, these three are the important forces for the whole this for Newton's first law and second law. After that we'll start discussing about the pseudo force and the friction forces, etc. So now we will be discussing about free body diagrams or FBD. So what is free body diagram? What is FBD? So this free body diagram will help us a lot in the whole Newton's laws of motion chapter, where we have to take every object and we have to study about it. So the first one, like the first heading is free body diagram. Now what is a free body diagram? This free body diagram is also represented as FBD. Now first there are some rules. There are two rules for free body diagram. First rule is represent the body as a point object. And the second rule is show all the net external forces acting on it. So show all the net external forces acting on it and represent the body as a point object. For example, here we are having a block of mass m again on the table. Now here you have to show what are the forces that the block is receiving on it. What the forces the block is applying, that we should not count. The surrounding is applying some force on the block of mass m. That forces we have to find. That is called the net external force. So first one is represent the body as a point object. So you have to study about this, whatever the forces are being acted on it. So what you have to do is take this block of mass m like this and represent it as m. Now show all the net external forces acting on it. First of all, for the block of mass m, mg is acting downwards. What is mg? Gravitational force. And this surface is applying a normal on it, normal reaction on it, n. So here it is n and down it is mg. That's all. This is the free body diagram of this thing. Now if you observe here, see what is normal reaction. Normal reaction is a force which occurs when the bodies are in contact with each other. Now here the block of mass m is in contact with the surface and the surface is also in contact with the block of mass m. The surface is applying normal reaction on the M. The M also applies normal reaction. But we don't show that normal reaction because it is not the net external. This is the force which the block is applying on the table, not the table on the block. So whatever forces it is applying, the block is applying on the surface, that forces should not take in account. Whatever forces the surface is acting on the block of mass M, that we have to take in account. So let us discuss some example over free body diagrams. First we'll take on pulley example. Here there is a pulley. Here there is M1. Here there is M2. Now here we should draw the free body. Draw FBD of M1 and M2. Okay. First take the block M1. In M1, what are the forces which are acting on it? First one, gravity, M1G. Up, tension. You know how to apply tension, right? Away from the point. Similarly in M2, down, M2G, and up, tension T. So, first one we are taking at it as M1. Here down, M1G, on the top, tension. For M2, down it is M2G, and on the top it is T. Now what if somebody asks you the FBD of the pulley? For example, if you want to draw the FBD of pulley, then here you see down C. Here tension will act away from the point. So here the tension will be acting like this, T over here, like this T over here. Why is this T and this T same? Because the string is same. Tension does not change until or unless the string is changed. Very important point. Here string is not changing, that is why the tension is same. So on the point P, here will be tension T1. Sorry, T only. Wait a minute. Point P. Here we have to assume that the pulley is massless, because in most of our cases massless pulleys will only be taken. If the pulley is massless, then there is no mg acting downwards. Here it is T, another one T, and up it is T2. Okay. Here it will be acting T2 away from the point. And why T2? Because the string has changed. Here this is one string which is going around, and this string is different string which is holding the pulley to the ceiling. This is how you draw a free body diagram. So I guess this is all the introduction which we need for starting the Newton's laws of motion. Now let us start with the Newton's first law of motion and what did he say about inertia. Let us see. So now we will be discussing about the Newton's first law of motion. So here Newton's first law of motion. What is the Newton's first law of motion? So first let me write down the complete definition. A body in rest stays in rest, and a body in uniform motion stays in uniform motion until or unless an external force is applied. So a body in rest stays in rest, and a body in uniform motion stays in uniform motion until or unless an external force is applied. Here we usually say a body in rest stays in rest and a body in motion stays in motion, but here motion means uniform motion. Sorry, not instead of uniform motion you can say constant motion. Sorry, it's constant motion, because constant is something else. Sorry, uniform is something else. Sorry, constant motion. So actually uniform motion means the motion increases slowly and constant motion means the motion keeps on, like the speed and velocity does not change. So a body in rest stays in rest and a body in constant motion stays in constant motion until a undesigned external force is applied. So this is the definition. Now if you want to summarize this definition into single line instead of remembering the whole paragraph, you can say that if F net is equal to 0, then A net is equal to 0. If the net force applied is 0, then the net acceleration is 0, which results in a body being at rest will stay at rest and a body at constant motion will stay at constant motion or will move in constant motion. So a body in rest will be in the rest and the body in constant motion will be in constant motion. So now imagine there is a block there is a block over here of mass m. Now if you don't apply a force, as I said in the starting, if you don't apply a force, the block won't move from its position. The block will stay as it is, that where it was in the starting. But here similarly the F net is 0. The net applied force. See here, net applied force can be not only the meaning of F net is equal to 0 or no force is applied. It means that the vector sum of all the forces is equal to 0. This is the meaning of Newton's first law of motion. So vector sum in the sense F1 bar plus F2 bar plus F3 bar is equal to 0. This F net is equal to 0, A net is 0. The body is not moving. That moving, the body not moving is called equilibrium. Equilibrium. So the Newton's first law of motion states that if the net external force applied on the object is 0, then the body does not move. So here if you don't apply the force on it, it won't move, the acceleration will be 0. This case is called equilibrium. So as I said, the vector sum of all the forces is 0. Why am I saying that? If a body is stationary over here and it is again on a table, so here mg is acting downwards, n is acting upwards. What is mg? Gravitational force. What is n? Normal force. But here if I say force is there is no force acting on the body, that statement will be wrong. Net external force acting on the body is 0. So n and mg, n is also being applied on the body, mg is also on the body, but n is cancelling mg. So the normal force is equal to the gravitational force. That is why the body is not moving. Or are you seeing that if there is a surface over here, if there is the block over here, is the block going up or down? No, because normal reaction is happening. See, now the block is in the rest only. But if we remove this and if we try to keep it, it will fall down, right? Because there is no normal reaction. Why there is no normal reaction? Because there is no contact. So here gravitational force will dominate. So here the net external force should be equal to 0. That is, the vector sum of all the forces is 0, and this condition is called equilibrium. This is only the first law of motion. So constant motion will move in constant motion. For example, a body is moving in constant motion. If you don't apply force on it, the body will keep on moving in its motion and the acceleration won't change. So if a body is moving in constant motion, the speed is not changing, it is just moving. If 10 meter per second at t is equals to 1, then 10 meter per second at t is equals to 10, like that. And if you are not applying an external force on it, then the object won't move fast. What is acceleration? Change in velocity by time. So here change in velocity won't happen. Acceleration, here we have to use derivatives. A is equals to dv by dt. Change in velocity by change in time. Now if you are not applying any force, there is no change in velocity. So the velocity is constant and derivative of constant is 0. Thus A is equals to 0. That is how net acceleration will be equal to 0. So this is the first law of motion. Now we will apply all the knowledge of the forces and the Newton's first law of motion, and we will start solving so many problems. So let us see. So now we have our first question over here. Find the tension in the strings. So here we have the ceiling, and here there is a 2 kg block and a 5 kg block. We have to find the tension in the strings. So first of all, what we have to do is mark the forces which are acting. Draw the free body diagram. For 5 kg, the free body diagram will be here 5G, okay, mg. So m is 5 kg. Tension will be what will be the value of tension? What will be the location? Tension will be away from the point. So away over here T1, okay. Now in 2 kg, down the tension will act T1 because the string is same. 2G will be acting downwards, and here there will be a tension T2. Now draw the free body diagram. First we are drawing the free body diagram for 5 kg, okay. Down the forces are 5G, and in the top the force is T1, okay. Now second case, 2 kg, down one force is 2G, there is one more force acting downwards which is T1, and in the top there is T2. Down there is 5G, up there is T1. Here 2 kg, down there is 2G and T1, and top there is T2. We have to make one assumption whenever there is Newton's laws of motion. First law, we should say that the system is in equilibrium. So the whole system is in equilibrium, it is not moving, it is still. So if it is not moving, take the first case. So here if it is not moving, this block is not doing any motion in the x direction and in the y direction. So up T1, down 5 kg, it is being cancelled. So you can say here T1 is equals to 5 into G value we can take 10, so 50. Now if you want to find, now here we got the value of T1 is equals to 50. What is the question? Find the tension in the string. So here T1 is 50. Now if you want to find T2, here the 2 kg block is not moving up or down. The 2 kg block is not moving left or right. It is in equilibrium. So the net external forces acting on the 2 kg block is equal to 0. So this T2 is equal to 2G plus T1. Okay. Here we should say T2 is equals to 2G, or we can say 20 plus T1, because the block is not showing any movement, it is stationary. So we can say that the block is in equilibrium. If it is in equilibrium, all the net external forces acting on the block are being cancelled. So that is why the top one and the bottom one are equal. T2 is equals to 20 plus T1. T2 is equals to 20 plus T1, we got here 50. So 50, T2 is equals to 70 Newton. Okay. So forces are actually measured in Newton. SI unit is Newton, CJ unit is dyne, etc. So T1 is equal to 50 Newton and T2 is equal to 70 Newton. This was our first question. So now let us increase our difficulty of the question by a little bit, and next we will be solving another question. So now we have another question over here. In the given figure, find the tension in the string. So the tension in the string is, so here we have two strings, we have to find tension in both the strings. So now here, if you want to try to solve this problem, you should know resolution of vectors. How to resolve the vectors into two x direction and one y direction. So if you want to know how to do resolution of vector, you can watch my video Vectors Part 1. So in that I have explained how to resolve a vector into two components. The tension in the string. Now there are two strings. So first of all, what you have to do is see what are the net external forces which are being applied on this block. First one, take tension. Let us suppose this is the tension T1. You know how to apply tension away from the object. Let us take there is a tension over here T2. Now we have to assign the net external forces such a way that they are either in x direction and y, they should be in x direction and y direction. So here 30, what we are going to do is this we will make into a z. Okay. So now interior opposite angles are same. So if this is 30 degree, this is also going to be 30 degree. Okay. Now let me write here T2. Okay. This is going to be 30 degree, and it is like this. Okay. What I actually did here was, this tension is actually over here with the making an angle 30 degree from this surface, that I have taken it and made a Z. See, if you want to find out the tension in any x direction, y direction, take the angle which is given and try to make it into a Z. So the angle at one end, so if this is the Z, this is 1 theta. So this, if this is theta, this will be also equal to theta, interior and opposite angles. So you can use this trick. So now T2, here there is the vector, here there is a theta given. So you know, if you are given the theta, wherever the theta is there we should use cos theta, and other side sin theta. So here it will be T2 cos theta, and up it will be T2 sin theta. Okay, and down 5g. This will be the weight. Now these are all the forces which are acting on that block. Now we have to draw the free body diagram. 5 kg. Down 5 into g value we are always taking it as 10, and we are taking the system is in equilibrium. If the system is in equilibrium, then only we can say that the x direction force, net x directional force and net y directional forces are equal. If they are equal, they will get cancelled out, then the resultant will be 0. That is how the acceleration will be 0. Thus it is in equilibrium. So 5 kg down 50 newtons. Okay. Now this direction force is T1. Okay. Now we will not be representing this T2. If you want, like you can say this is T2. This is 30 degree T2 cos 30 sin 30. Instead of that, we will not represent the T2. We will represent it the forces which are only in the x direction and the y direction. So here the force is T2 cos theta. T2 cos theta. Okay. In the top, T2 sin theta. Okay. So here T1 down 5g, here T2 cos theta, and up T2 sin theta. Now we know that the whole system is in equilibrium. So the net forces on the x direction and y direction. So x is equal and y is also equal. So first we'll first find the T2 because it is much easier. Now here theta is actually 30 degree, right? So instead of theta, let us substitute 30 degree. Here also 30 degree, 30 degree and 30 degree. Okay. Now first we'll do T2, or else we can take T1 also. So here we know T1 is equals to T2 cos 30 degree. Okay. And another equation which we can get is T2 sin 30 degree is equals to 50 Newton. Okay, these two equations we got. Now first we will try to find T2 because we know two values in this. Now here T2 sin 30 degree is equal to 50 Newton. Okay. Now 30 degree. What is sin 30? It is 1 by 2. So T2 into 1 by 2 is equals to 50 Newton. If you want to find T2, this 2 will go over there. T2 is equals to 100 Newton. Okay, we got T2 value as 100. Now we know the T2 value, we should find the T1 value. So this one we got first option answer. T2 is equals to 100 Newton. Now we know the T2 value. T1 is equals to T2 cos 30 degree. Okay. Okay. Here T2 is what? T2 value is 100. So T1 is equals to 100 into cos 30 degree is root 3 by 2. 2 ones are 2 50s are. So here T1 is equals to 50 root 3 Newton. This is our second force of T1. Okay. Here what we did was 5 kg block has two tensions over here, T1 and T2. T2 sin 30 degree will be upside, T2 cos 30 degree will be this side. What we know is the system is in equilibrium. So net external x direction force is equal to the net external y direction force. So here T1 is equal to T2 cos 30 degree and T2 sin 30 degree is equals to 5g or 50 Newton. Now T2 sin 30 degree is equal to 50 Newton. T2 into sine 30 degrees 1 by 2. So 2 will go over here and become 50. 250 into 2. T2 is equals to 100 Newton. We know the value of T2. Now we can easily find the T1 answer. T1 is equals to T2 cos 30 degree. T2 value we know 100 Newton. So 100 into cos 30 degrees root 3 by 2. So thus T2 we got 50 root 3. Now let us move on to the next question. So now we have a question over here. Find the tension T2 and the mass of the body. This is the figure which has been given to us. Now here they have given one tension value. Here we have to find the mass this time. They have done some changes in the question. We have to find the mass of the body. And which is the tension T2 over here? This will be our tension T2 over here. Okay. So this we have to find out. What we have to find out the mass and the tension of the body. So that such that it stays in equilibrium. Okay. So this full this full video will be on equilibrium problems only. So for equilibrium, here 30 Newton has been given. First you have to write down what are the forces which are acting on the block. So here T2, so this is 30 degree, so this side will be T2 cos 30 degree. Okay, we are connecting it like this, and then here it will be T2 sin 30 degree. Okay, here 30 Newton force is acting here, and down it is mg. We have to find the m over here. Okay, so we know the we know only T1 value. So let us draw the free body diagram. Mass m. Here we are having 30 newtons. This side we are having T2 sin 30. Up we are having T2 cos 30 degree. And down we are having mg. Because the body is in equilibrium, the net external forces acting on it is equal to 0. The body is not moving in x direction or in y direction. So here, first we are having T2 sin 30 degree is equals to 30 Newton. Okay, this force is equals to this force because the body is not moving left or right. T2 into sin 30 degrees 1 by 2, it is equals to 30 Newton. T2 is equals to, this 2 will go there, 60 Newtons. Here we got the answer to our first question, find the tension T2. We know the tension T2 value is 60 Newton. Now we have to find the mass of the body. Now second equation is T2 cos 30 degrees is equals to mg. T2 cos 30 degrees is equals to mg. Cos 30 degrees root 3 by 2. And what is the value of T2? We know 60. So 60 into root 3 by 2 is equal to mg. Okay. 2 ones are 2 30s. Okay. So 30 root 3 is equals to mg. We have to find m, not mg. So here we have given we have to find the mass of the body. If they ask the weight of the body, then this will be the correct answer. If you want to find the mass of the body, then let me write over here. 30 root 3 is equals to mg. We are assuming g value is 10. So 30 root 3 is equals to 10m. This 10 will come in denominator. So 30 root 3 by 10 is equals to m. 3 root 3 is equals to m. So this is the mass of the body. Now in the exam there will be both this option and this option. If you mark this option, this will be wrong because they have asked the mass of the body. If they ask the weight of the body, then this option will be correct. So what we did here, we have to know how to resolve the vector. We resolved it into two components. One was T2 cos 30, one was T2 sin 30. All the forces are equal in the same direction. So 30 and T2 sin 30 is equal. Mg and T2 cos 30 is equal. Then we use these equations and then we found the value of tension T2 and the mass m. So now let us move on to the next question regarding the equilibrium or Newton's first law of motion. So we will be continuing the questions, but before moving on to the questions, we have one more topic left in Newton's first law of motion, that is about inertia. So what is inertia? So actually before Newton gave his first law, Galileo made his law of inertia. This law of inertia, the body in rest stays at rest, body in constant motion stays at constant motion. This is called the inertia. Now, inertia is of three types: inertia of rest, inertia of motion, and inertia of direction. So, what is inertia of rest? The ability of the body or the inability of the body to change its state of rest. By itself, it is called the inertia of rest. So, what is inertia? The inability of the body to change its state of motion is called inertia. If the body is in motion and is unable to change its motion because there is no net external force applied on it, so that is called inertia of motion. If the body is unable to change its direction, or you are providing some force so that it changes its direction. For example, now you are standing on a bus, and if you are standing in a bus and then suddenly the bus accelerates, then you will feel a backward jerk. This thing is because of pseudo force, the backward jerk. But why are we feeling that backward jerk? Because of inertia of rest. You are standing, you are at the rest. Suddenly if somebody is pushing you, the leg is going with the bus because it is in contact with the bus. But the upper half of the body, it is still in the rest. So the bus moves forward, but you are still remaining in that place. So the bus goes forward and the body is backside. Body goes backside. But our nervous control system is so it is advanced than others. So that is why as soon as we get the jerk, we come back to our own original place. This is inertia of rest. Inertia of motion. If the bus is moving and if the driver suddenly applies the brake, we experience a forward force. See, this thing will be explained like you are in the rest and the bus is moving, accelerating suddenly. Bus is accelerating in front direction. Why are you feeling a backward force? Because of pseudo force. Body is moving. You are applying brakes. Brakes are applied in the opposite direction. Why? We are going in front. These all things are explained by pseudo force. We will be discussing that in another video. Now, inertia of motion. You are standing in a bus and driver applies brake. So, your lower half of the body is still in the motion, but the the lower part of the body comes at rest. Why? Because it is in contact with the bus. But your upper half of the body is still in the motion track only. So it takes some time for it to come back to the rest. If you gradually apply the brakes, then you won't feel the jerk. But if you apply the brakes suddenly, you will experience a force. That is called pseudo force, and that is by inertia of motion. Inertia of direction. Now, for example, you are in a car. If you are moving towards the left side, you feel a jerk towards the right side. Why? Same because of pseudo force and because of inertia of direction. This was the concept of inertia. Now let us move on to the next question about the topic of equilibrium. So now we have another question over here. Find tension in both the strings. Now here we have the first string and here is the second string. We have to find the tension in both the strings. So here, first of all, we have to resolve it into x and y components, so that the net external forces which are acting on the root 2 kg block, they should be in either x direction or y direction. So here 60 degree, we have to resolve it into two components. Here let us take it is T1 and here let us take it is T2. Okay. Now here it is T1 cos 60 degree and here it will be T1 sin 60 degree. T1 sin 60 degree. Okay. T1 sin 60 degree. Now here the 30 degree, here the angle is 30 degree. So we are taking the tension as T2. Here it will be T2 cos 30 degree and over here it will be T2 sin 30 degree. And down the gravitation force will be acting root 2g. These are all the forces which are being applied on this block. So now we have to draw the free body diagram. For the free body diagram, let us take this is the root 2 kg block. Down gravitational force root 2g, or we can take root 2 into 10, so root 2 into 10, 10 root 2. Up there are two forces, T2 sin 30 and T1 sin 60 degree. So we can write T2 sin 30 comma T1 sin 60 degree. Okay. Now in this direction the force is T1 cos 60 degree. T1 cos 60 degree, and in this direction the force is T2 cos 60 degree. These many forces are being applied on a single block, but still the block is in equilibrium. The block is not moving. That is what we say, that the net external force on the block is 0. There are so many forces, but each forces cancel out each other so that the body does not move. Now let us start finding the tension. First let us take this one, T2 sin 30 degree plus T1 sin 60 degree is equals to 10 root 2. Okay. Up there is T2 sin 60 degree and root 2g. Okay. Up there is T2 sin 60 degree and T1 sin 60 degree. Forces are upside, and down there is 10 root 2. So T2 sin 30 degree plus T1 sin 60 degree is equals to 10 root 2. The second equation is T1 cos 60 degree is equals to T2 cos 60 degree. T1 cos 60 degree is equals to T2 cos 60 degree. Now T2 sin 30 degree. T2 into 1 by 2 plus T1 into root 3 by 2 is equals to 10 root 2. This will be plus plus, the common LCM is 2, so this 2 will go in the numerator side and the right hand side. So T2 plus root 3 T1 is equals to 2 tens are 20 root 2. Okay, 2 into 10 into root 2, so 20 root 2. So T2 plus 3 into T1 is root 3 into T1 is equal to 2. So now this is one equation which we got. Now second equation, T1 cos 60 degree and T2 cos 30 degree. So here I am changing this into T2 cos 30 degree, and here also T2 cos 30 degree. Okay. Now this equation we are getting this value. Now we'll stop for till here. Now here we are going to use this equation, T1 cos 60 degree is equals to T2 cos 30 degree. T1 cos 60 degrees root 3 by 2 is equals to T2 cos 30 degrees is equal to 1 by 2. This 2 and this 2 will get cancelled. So T2 is equals to root 3 T1. This is one equation which we got. So T2 is equals to root 3 T1. Root 3 T1. Now we are going to use the second equation once again. So T2 into 1 by 2 plus T1 into root 3 is equals to 20 root 2. This was the equation which we got. Now T2 is root 3 T1. So root 3 T1 plus T1 root 3 is equals to 20 root 2. This is the equation which we 20 root 2. So here actually T2 is equals to root 3 T1. So here we will get root 3 so here T2 plus root 3 into T1 into root 3. So here root T2 plus root 3 into root 3 will give you 3. T1 is equals to 20 root 2. Root 3 T2. So 3 T2 plus T2 is equals to 4 T2 is equals to 20 root 2. T2 is equals to 20 root 2 by 2. T2 is equals to 5 root 2 Newton. Okay. So this is the value which you got. So T1 cos 60 degree is equal to T2 sin 60 degree. So T1 into 1 by 2 is equals to T2 into root 3 by 2. So T1 is equals to root 3 T2. T1 is equals to root 3 T2. That we used and we got this equation. So T2 plus T1 root 3 is equals to 20 root 2. T2 plus root 3 T1. This actually T1 we know the value, it is root 3 T2. So that instead of T1 we used root 3 T2. Root 3 into root 3 is equals to 3. So T1 T2 plus 3 T1 is equals to, sorry, this also will be T2 only. is equals to 20 root 2. So T2 plus 3T2 is equals to 20 root 2. 4T2 is equals to 20 root 2. T2 value we got 5 root 2 Newton. Now if you want to find the T1, T2 value we got 5 root 2. This T2 value we can substitute in this equation and then we will get the answer for T1. So T1 into 1 by 2 is equals to 5 root 2 into root 3 by 2. So if you solve this equation, you will get the answer for the T1. So thus we got our tension values. So this was our question. Find tension in both the strings. So now let us move on, or before moving on, so here let us first find out the tension T1. What is it? So and here if you want to find the value of T1 is equals to root 3 into 5 root 2. This is the value for T1 if you want to find T1. So this was a confusing question. Let me do it again once again. So here these many forces are being applied on it. So what we did was T2 sine 30 degree plus T1 sine 60 degree is equals to 10 root 2. So and another equation which we got was T2 cos 60 degree is equals to cos 30 degree is equals to T1 cos 60 degree. Now in this equation we used to find the relation between T1 and T2. The relation between T1 and T2 is T1 is equals to root 3 into T2. Now second, this equation we used T2 into sine 30 degree, which is 1 by 2, plus T1 into sine 60 degree root 3 by 2 is equals to 10 root 2. This equation we got as the answer. Now in this equation we substituted the value of T1 which was given over here. T1 is equals to root 3 into T2, so root 3 T2 into root 3. Root 3 into root 3 is equals to 3. So T2 plus 3 T2 is equals to 20 root 2, because the 2 we took it to that side. 4 T2 is equals to 20 root 2. T2 is equals to 5 root 2 Newton, and that T2 we substituted in our this equation. Now let us move on to another question for the equilibrium concept. So now here we have to find the weight of the block, not the mass. We have to find the weight this time. So T1 value is given 10 Newton. Here we are taking T2. We have to make a Z over here. So this 60 degree is equals to here 60 degree. So here we will get T2 cos 60 degree, and the another component will be T2 sin 60 degree. Okay, and down the weight will be acting mg. Draw the free body diagram. Here 10 Newton, down mg. This is the free body diagram of mass m. Here T2 cos 60 degree, and here T2 sin 60 degree. This is the free body diagram. Then here T2 cos 60 degree is equals to 10 Newton. T2 into 1 by 2 is equals to 10 Newton. T2 is equals to 20 Newton. This is the tension 2 value. Not asked in the question, but still T2 is equals to 20 Newton. Now T2 sin 60 degree is equals to mg. T2 value is 20 into sin 60 degrees root 3 by 2. 2 1s are 2 10s are. So mg 10 root 3 is equals to mg. This is our final answer. So we wanted to find the weight, and this is the weight, 10 root 3 kg. 10 root 3 Newton is equal to mg. Now let us move on to another question, the last and final question of this video. Let us see. So this is our last question for today's video. The question is find theta, normal and tension. This is the theta, the angle, and normal reaction, and T tension. So here this is our diagram over here. So first let us draw the 3 kg free body diagram. Down 3G is being active, top tension T. Now 5 kg, here we have to use one concept. We will not be using mg directly. We will be using the components of mg. Components of mg will be, like, if this is the mg, this side will be mg sin theta, and this side will be mg cos theta. Okay, here is the theta, so here also theta, then this component will be cos theta, this component will be sin theta. That is how you will get mg sin theta and mg cos theta. This arrow will be in between actually. So once you find the components, you don't need to represent the like mg. We can directly use the components. Why we are doing this? Because we want the components should be arranged in one specific plane. Now here there is no specific x plane, so we are taking this plane as the x plane and this plane as the y plane. So here this is mg sin theta, mg cos theta. Here the tension is T, and here there is the normal reaction. Draw the free body diagram of 3 kg. Down there is 30 Newton. There is tension over here. One more case, the whole system is in equilibrium, so it is not moving. Now if you are drawing the free body diagram for 5 kg, this side there is tension T, down there is mg sin theta, or else you can take 5g sin theta. Here there is 5g cos theta, and here there is normal reaction. So everything is in rest. It is in equilibrium. Let us take this first. So first we can find the tension. So tension is equals to 30 Newton. Directly we can say, because it is in equilibrium, it is not moving, so both the forces are equal. Tension we got 30 Newton. Now normal we can find. N is equals to 5g cos 30. 5g cos 30. This is the value for the n. Now here T is equals to 30 and n is equals to 5g. T is equals to 30 Newton, which we found over here. Now this direction, that is T, right? So T is equals to 5g sin theta, equals to 5g sin theta. T value we know 30, so 30 is equals to 5g sin theta. Now we have to find the sin theta. So 30 by 50 is equals to sin theta. 0 0 will get cancelled. 3 by 5. So you should remember this triangle. If the theta is over, if 37 degree triangle, 3 is over here, 5 is over here, 4 is over here, and there is one more triangle, that is 53 degree triangle. Here 4 will be here, 5 will be here, and 3 will be here. These two triangles are very important. So here sin theta is opposite by hypotenuse. Opposite here is 3 and hypotenuse is 5. So 3 by 5 is equals to sin theta. Sin theta is equals to 37 degrees. This was ours. This part, find theta. Now theta we got 37 degree. So normal also we can find. Normal force N is equals to 5g is 15 into cos theta. Cos 37 degree is equals to 4 by 5. 5 ones 5 tens. So normal is equals to 40 Newton. So we got the tension 30 Newton, we got the normal force 40 Newton, and we got the theta 37 degree. So that is it for today's video. In today's video we have discussed about Newton's first law of motion. What are forces, what are the types of forces required for this Newton's laws of motion. So I hope you have enjoyed this video. If you've enjoyed this video, do subscribe to this channel, like this video if you find it informative, share it to your friends. See you next time in the next video. Thank you and goodbye.